Hi everyone, my name is Amitesh, and in this video we're going to master this limit over there and talk about the secret method of the dominant term. So once you've seen it once, you can solve any kinds of limits like this where x is going to infinity or minus infinity. And this limit is, as I've taught multiple times at Princeton University, it's appeared on exams or similar style limits. I've given lectures on understanding these kinds of limits via dominant terms, so I hope this will be helpful for you. So let's just dive right into it and try to understand how we calculate this limit. So the first step is always just to plug in and see what is happening to the numerator and denominator as x is going to infinity. Okay, so that's the very first step, step one. So let's just think about this. So we've got 3x squared minus 4x plus 2. So as x goes to infinity, the idea you want to think about intuitively is that the 3x squared dominates. Okay, so what this means is that the negative 4x plus 2, even though you're subtracting off a 4x, if you think about x is 10, for example, 3x squared is going to be 300, the 4x is just going to be 40. So it's 300 minus 40. But when x becomes bigger and bigger, the 3x squared is simply going to overpower the negative 4x. So the difference is still going to go off to infinity. Okay, so you can convince yourself of this by thinking about bigger and bigger numbers. If you think about x is 100, you've got 3 times 100 squared, which is 30,000. And here you've got just negative 400. Okay, so the 4x is never going to compete with the 3x squared. And this is why we think of this as the dominant term. Now this is going to be very crucial when we're actually going to try to understand how to find this limit. But at the moment, we know that the numerator is going off towards infinity as x goes to infinity. Okay, so that's step one. And so it's not really infinity minus infinity. Okay, so you're not literally plugging in infinity squared minus 4 times infinity. You just have to understand, as I've explained, why the top is going to infinity because of the dominant term 3x squared. And similarly on the bottom, you've got the same deal. It's slightly different here though, but it's the same idea. Here you've got the negative 2x squared. And as x goes to infinity, x squared is always going to be non-negative, but the negative 2x squared is going to make it negative, and it's going to overpower the fact we're adding a 5x. Okay, the 5x is simply not going to compete with the negative 2x squared, and the denominator is going to go off to minus infinity. And again, the idea is the same as before. And of course, the plus 2 and the plus 7 are irrelevant here. They're just too small, so it doesn't really matter as x goes to infinity. Even the negative 4x and the 5x weren't enough to make a dent in things. So this is an infinity over infinity limit, or an infinity over minus infinity limit, however you want to call it. So how are we going to understand this limit? And it is a secret trick, but it is intuition guided. Okay, so in math, people come up with these tricks. It does take time. But the intuition is that the 3x squared and the negative 2x squared are what are kind of controlling the limits on the top and bottom. And we can actually make this infinity over negative infinity thing even more precise than what I've said about subtracting the 4x and it not competing with 3x squared by the following trick. So it's going to be, what we're going to do is, we're simply going to factor out a 3x squared or an x squared from top and bottom. Okay, so what we're going to do is we're going to factor out an x squared from the top. And when we factor out an x squared from the top, what we're going to get is we're going to get the following expression. Well, it's going to be 3, right? Because 3 times x squared is 3x squared. When you factor out an x squared from negative 4x, it's going to become negative 4 over x. Okay, so your x is going to be from x power 1 to x power negative 1 because you're factoring an x squared. So it's going to be negative 4 over x plus 2 over x squared. Okay? Now, you can check, it's good to just check mentally that you multiply it out, you get 3x squared minus x squared times 4 over x is minus 4x, and x squared plus 2 over x squared is 2. Okay, so you've really got this expression, and now you can really see what's happening. Okay, just if we pause for a second, we see that as x goes to infinity, this expression in the brackets, what's happening to the 4 over x and the 2 over x squared? Well, you're dividing by a very large number, right, as x goes to infinity. So all of this is just going to go to 3. Okay, so the infinity part is coming from the x squared. We've isolated that out, and it's the same with 0 over 0 limits. When something is going to 0 over 0, there is a culprit on the top and bottom that you can isolate out and cancel off, and it's going to be the same thing here. So let's do the same thing on the bottom. Let's factor out an x squared, and I want you to try to understand what we get. Okay, so pause the video if necessary and work out what happens when you factor out an x squared. But assuming you've done that, I'm just going to dive into it. So what we're going to do again is we're going to get negative 2. Okay, so that's the first part, which is the simplest. Then we have the 5x. So another way of thinking of it is you're dividing the whole thing by x squared. Okay, so I'll write that out too. But you can sort of think 5x by x squared is going to be 5 over x. And 7 by x squared is going to be 7 by x squared. Okay? So when we factor out the x squared, we're going to get this expression here. And that's going to still be an infinity over negative infinity limit. But we can actually now cancel off the culprit, which is creating the infinity on top and bottom, which is the x squared. Okay, so we can cancel that off, and that's going to be the crucial observation. So cancel this off on top and bottom. And now what we're going to get is we're just going to get, I'm just going to write it down here. It's going to be limit x goes to infinity of 3 minus 4 over x plus 2 over x squared divided by minus 2 plus 5 over x plus 7 over x squared. Okay, so that's going to be top and bottom. And now the cool thing is we can plug in. Okay, so it's always the same. With 0 over 0 limits, cancel the culprit on top and bottom, plug in. Infinity over infinity limits, we cancel the x squared on top and bottom, plug in. As x goes to infinity, as I said, we're going to get, this is going to go to 0. This whole thing in red is going to go to 0 because you're dividing 4 over x plus 2 over x squared. X is going very large. It's going to go to 0. Similarly, this thing is going to go to 0. So the 3 and the negative 2 are what remain. And so in conclusion, we get limit x goes to negative of infinity of this is simply going to equal to 3 over negative 2, which is equal to negative 3 halves. So that's going to be the answer for the limit, and that's the solution of the problem. Now, if you watched this far, please like and subscribe. It means a lot to me. My goal is to create free, accessible math education worldwide. I'm going to end with one more comment, though, before I get into those things, is that if you think about this, this thing, you sort of see that the end answer was negative 3 halves. It was kind of the highest degree x term and the highest degree x term. We looked at their coefficients and we simply divided them. Okay, so we got 3 over negative 2, and that is a pattern with these problems. It wouldn't have mattered if I had an x cubed and x cubed here. It would still have been 3 over negative 2. We just have to divide top and bottom by the x cubed. So when you're thinking about limits like these with dominant terms, you think about the highest power of x on either top and bottom and divide by that out. Okay, and once you divide out by that, you're basically going to get something like this where you can literally plug in, you've canceled off the culprit, and you get the answer. Okay, so that's going to be the general strategy. And I just want to comment that in terms of graphs, this is going to correspond to what's called a horizontal asymptote. Okay, so I'm going to write this out. This is an important concept. We'll talk about this more in other videos too. This is a horizontal asymptote at y equals to negative 3 halves. Okay, so what does this mean exactly? It means that the y value of this function inside the limit approaches negative 3 halves as x goes to infinity. So what that means is the graph is going to approach the line y equals to negative 3 halves. Okay, so I'm going to just erase that and just show you a depiction. It's not necessarily going to be for this function. I'll do other videos where I graph such functions. But if you have like something like this, it's an xy plane, then what you can do is you can say y equals negative 3 halves. You can draw that line, and you're going to get this line y equals negative 3 halves. And what's going to happen to the graph is it's going to approach, because the y values approach that line, it's going to look something like, it depends on the exact problem, but it could look something like this, where the graph is kind of steadily approaching the line as x goes to infinity. Okay, so I'm not saying this is the graph of this function, but generally speaking, this is what they prototypically look like, and I'll do other videos graphing functions. So thanks so much for watching. I hope you loved this video on the idea of a horizontal asymptote and dominant terms in infinity limits. Please leave a like, subscribe, share with friends and family. My goal is to help as many people as possible, irrespective of what high school, college, etc. they attend. I want to give you elite math education straight to your room, and by liking and subscribing, you help notify yourself of infinite math content at all levels, so you'll never miss anything. But also, you really help me support my vision of changing lives through math education, which is my ultimate goal. So I wish you all the best, and I'm super excited to see you in the next video.